Section 4.5, Exponential Functions, Part 4. Equations involving exponential functions. Okay, if we remember the process is to isolate the exponential. In order to undo an exponential, we logarithm. Logarithm of the same base is preferred, but if we need to use our calculator, then base E, ln, or base 10, log, are the best. For problem number 40, since we're solving, let's first start out by getting one side equal to 0. If we get one side equal to 0, that's our usual when we have a quadratic equation. Now that one side is equal to 0, what do you notice? You should notice that 10 to the x is common in everything. When factoring out the greatest common factor is always the first step. So we have 10 to the x, then we're left over with x squared minus x minus 2 equals 0. If we factor, that would be x squared minus 2, x minus 2 times x plus 1, factoring our quadratic. Now the zero product property comes in. Each of these is set equal to 0. Setting these each equal to 0, we could start to see some solutions that are possible. Now, exponential graphs, remember, have the horizontal asymptote at the x-axis, so 10 to the x never touches or crosses the x-axis. So what that means is we don't have a solution from that part of our equation. Okay, here we have x equals 2. Here we have x equals negative 1. I'm going to go ahead and box both of those as solutions. Okay, solve a logarithm equation. Now we're looking at something different. To solve an exponential, we use a log to get rid of it. If I want to solve a log, what undoes a logarithm? What's its inverse? The inverse is an exponential. So if I want to solve a log, to undo a log, I exponentiate. Okay, notice some similar steps. Isolate first the logarithmic term. How do I get rid of the log? I exponentiate. Then I solve for the variable. Okay, let's look at both of these. These are log base 5. So what we're going to write is log base 5 of x times x plus 1. Okay, what gets rid of log base 5? That's an exponential base 5. This is the new exponent of 5. We have exponentiate base 5. Okay, so exponentiate, this becomes the exponent. Why did we want to do that? Well, if we look at exponential base 5, log base 5, inverse functions, those cancel one another out. Exponential log base 5, those cancel out. And so what are we solving? We're solving x squared plus x minus 20 is equal to 0. I went ahead and distributed the x, and I subtracted the 20, so I have one side equaling 0. Solutions when we're factoring, x plus 5 times x minus 4, x equals negative 5, x equals 4. I'm only going to use this as a solution. Why? Okay, what happens when I plug in my solution into this original equation? We would have log base 5 of negative 5 plus some stuff. In your calculator, or not, since it's a base 5, remember your domain of logarithms. You can't plug in 0, and you have to plug in positive numbers. So this is out of the domain of a logarithm. So this will not produce a solution. Okay, what's our answer? X equals 4.